días tengan todos ustedes, comunidad Politécnica y otras instituciones que nos hacen el favor de acompañarnos esta mañana. Sean todos bienvenidos a este segundo día de trabajos del quinto Congreso Internacional de Investigación en Medio Ambiente, aquí en el hermoso lugar de Boca del Río, Veracruz. Esta mañana tenemos con nosotros una conferencia magistral extraordinaria con un excelente ponente que viene de los Estados Unidos. La conferencia magistral será dictada por el doctor Virender Sharma de la Universidad de Texas A&M y estará coordinada en la mesa por el doctor Jonathan Muthuswamy Ponia del CIIEMAD. Muchas gracias por su asistencia, sean todos bienvenidos y adelante, doctor, si es tan amable. Adelante, Jonathan.
I will give a brief introduction. Please. Quiero leer el currículum de doctor, es un poco muy largo, pero ya vamos a tratar concisar, ¿no? El doctor tiene, la más importante es, tiene 40,000 citas de publicaciones, 445 publicaciones en las revistas indexadas. Y es editor, y aparte en comité editorial, en varias revistas internacionales y 36 volúmenes del Congreso, y aparte está en top 1% en Web of Science. Entonces también es el profesor distinguido en el Texas A&M Universidad. Entonces y más de 220 conferencias invitadas. Sí tiene más, pero sí va a tardar más. Entonces con eso currículum ya tenemos una buena profesor aquí. Bienvenido, welcome. And I was just giving a short introduction about your CV. It's very long, but we respect and we have a great speaker today. Thank you.
Muchas gracias. Buenos días. And I'm very happy to be here. And I really thank you so much to Dr. Jonathan and Dr. Judith who invited me, and all the distinguished scientists you are, and also the young scientists, our future. And thank you very much for coming and this morning. And I think it's still considered morning, early morning. So with this, I'll start talking about my presentation. And please do ask me many questions, and you can stop me anytime. Don't wait till the end and you forget the question later on. And if I don't know the answer, I'll try to find the answer later and send you. But normally what I play sometime trick. If I don't the answer, I say, okay, I'll come back, and I just disappear. Okay. So with this, again, welcome for my talk. And how to move this one? You can show me maybe. Which one I need to push? Okay. Thank you, sir. So let me introduce, if you are not familiar with Texas A&M, M is agriculture, M is mechanical. Historically, it is more than long time this university, but we offer too many degrees, more than 170 degree, enrollment of about 75,000. So when I joined, it was around 50,000, but then basically it has gone to 75,000. And we receive a lot of funding, number 4 from National Science Foundation. and we have academy members, 76. The academy member of science, academy member of engineering, and so we have more numbers we have, better it is. So, and other things about this, you can see best universities in state of Texas, and then is first in nation for number of students studying abroad. So we send many students to go abroad. And also this the aerial view of the campus on the left side. And then is Bush Science, Bush Library. Presidents, after they retired, they have library on their name, and it happens to be in our campus. So if you visit me, I'm sure, please visit me. And then that's the place I'll take you, because we have nothing else to show. So this is the library that you will visit, and you see the car he drove and all those things, his life, how he grew up there. And this is my School of Public Health on the left side of this one. And the height-wise, the building section is for whom? This is for administrator. They always get everything. So they have these buildings. And then we have on the right side is teaching classes. In the middle is labs. And the lab, I'm working very hard. You can see here, I look serious enough, right? So you think Dean will give me some more money? Okay, that's the idea at least. Okay, and I work a lot on RN molecule. So so magazine in Texas A&M, they say I'm the real RN man. Okay, and not today, but if I come back in future, then I'll convince you after so many research I do on RN molecule. To me, it's very fascinating. RN molecules that I intend to show. And just to justify why I'm here in terms of climate change, so my idea is topic is very narrow. I found when I started making abstract, when Dr. Jonathan asked me. So now I have expanded, so you'll get a lot of information in my presentation. Just note on microplastic, you get all kind of pollutant information. And we have an issue, basically the world will gain 2.7 billion people by 2050. So we may have close to 9 billion people. And how we are going to feed those many people? And we have a water issue too, and we have food issue, and then energy issue, how we like to drive more and more and bigger cars, and how we are going to sustain it. And so interesting thing is the last one is 40% of residents currently lack access of improved water. So, and then we have a climate change is going to really create many problems. Actually start seeing here, water is one of the big issue about climate change. And then yesterday somebody was asking questions. Don't forget we have many pathogens comes out when you change the climate. And also somebody also asked the questions or mentioned the comment, we'll have a problem of cyanobacteria. More and more will come out. And because climate change means high temperature, you will see more algae growth. You all start seeing. If you see the whole preference of people, they like to live close to water. And that close to water means they are putting more nutrients into the coastal water that create basically algae and then cyanotoxins. And this is what basically this complex way it is going to change water cycle, climate change to go change the water cycle. And this is just to show current urban water scarcity is probably any place will have a shortage of water. Clean water basically. And this is a very good article, Nature Communication. This is not my article. So 10 million in this year, water scale, urban population, global scale. So we do have, and Mexico shows up somewhere here too, that we have a issue with the water. And just to give you, I have historically very close with Mexico by heart and research-wise. I came first time, I think it's 89. Long time ago, maybe once upon a time, and since then I published several papers with in Campeche area, metal pollution, muchacan, and also some egg and turtle exocontamination, and also petroleum hydrocarbons. So I've been involved in Gulf of Mexico research, and what is going to change? Just climate change will not change only water, but will have an effect of on the food. Okay, if water get contaminated, and we are using water to grow food, so all contaminated water it will get transferred into food and we consume. Think about that situation here. So bacteria, fungi, and people do get quite often sick. About this one. For food, we use a lot of water to grow food actually. Our 70% of our water consumption actually growing the food, so we can feed the people. So I challenge the young scientists and or not so young scientists, because I don't like to use the word old. Okay? So not so young scientists, I challenge how you can grow more food with less water. I think it's possible. So that's what I'd like to challenge the young scientists. Even you 10%, 20%, you consume less. Think about the green revolution when it happens. People were starving in India, and that saved many lives, green revolution. And just, they changed the genes and doubled up food growth, food production. Same thing, I'm sure, one can grow food with the less consumption of water. Otherwise, you use a lot of water. Virtual calculation was done by International Water Association. It requires 70 liters of water to grow one apple. Think about that. So it requires, and here, so there is what I'm trying to give big message here, that you have a food, water, energy. They're all now United Nations is going after sustainable growth, sustainable infrastructure, sustainable water production, and what you need to care about is how we can get the sustainability. But you know, Iron Man is around, and who know who's the Iron Man, real Iron Man will solve the problems. And real Iron Man is doing research on iron molecule. So that's what I'm doing, the research on iron molecule. And this one, I can disinfect bacteria, clean the water, clean the food, and clean hospital. And you know, we suffer a lot during COVID. And COVID is virus, and that is easy to be cleaned in the especially hospital surfaces. I know even United States is a big problem. I visited more than 100 hospitals and learned a lot, because I'm basically marine chemist, environmental chemist, and I become environmental health person and try to control infection disease. And that is big problem. Every year US spends 70 to 80 billion dollars just to minimize the infection disease. Because people go to hospital, and I also suggest you don't go to hospital unless you have to go, because once you go there, you take care of your surgery, whatever, but then you acquire the infection. And then you have to go back to hospital to take care of that infection. So please be healthy, walk a lot, and I'm not supposed to say, but I'm still say, eat less. Okay? So here is the molecule I work on. I give some example, then come back to what kind of pollutants. This molecule, ferret 6, is basically high oxidation state of 6, plus 6. Normally you read in your textbook is plus 2 and plus 3, and that is ferrous-ferric. Here is 6, which can oxidize antibiotics, because that's the big problem of antibiotics. In Mexico also use lot of antibiotics. Okay, you can go to any pharmacy store and get all kind of antibiotics, and then we disinfect the bacteria, virus, and we can remove arsenic. For example, arsenic is also some part of Mexico. We have arsenic. So one molecule can do. Let me give example quickly. This is a patent technology. I don't want to talk too much about this. I'm trying to commercialize it. Here is, you can see food. You can disinfect the food, or this is just to show the spinach. You just dip in the solution which I showed you. This solution you just dip, and then you get fresh spinach and no E. coli growth there. And then you can also do the meat product, fish, shrimp. This shrimp is very big industry in Mexico, and you can just dip and then clean the seafood. And virus, you can clean the human virus using this molecule. And here is, we have a data, or not my lab has the data to show coronavirus can be disinfected by this molecule. And you can see here on the right side is 6 here, start is there and nothing left. So you can also clean the surfaces in hospitals or wherever that you think we have this coronavirus. And here is microcystine, which comes out from the cyanotoxins. You can destroy these cyanotoxins, but it hits the brain, nerve system. This molecules can basically, this the example on the top is the example where we have, there's 2 weeks, there's no water in Toledo because they found the cyanotoxins there. And there are many, many examples you can see all over the world, but this is going to grow no matter what. We are not going to change our lifestyle. That's the way we are, humans. So that means we'll have more of cyanotoxins, and that we need to take care of it, and especially algae growth. And here is, this the yellow thing you see is the double bond, which really is toxic. Double bond toxic. So ferret, what it can do is this iron molecule can destroy double bond, and basically no more toxic. And this is also slendropomopsin, which came out this year, which can also be destroyed by this molecule. So what I try to give this just a few examples, but that's not the focus of my presentation. I just want to give you feeling, because that there is solution is on the way. And here is, I want to talk, again, if you have any question, please stop me and I'll explain. And we have so many micropollutants in the environment. Which micropollutant water environment deserve more attention? United States and globally, right? That's the question. Normally I see people go and determine, can you have a water, please? Big thing is pharmaceuticals and personal care products. And then we have pesticides, and we have industrial chemicals, dioxin, chlorinated solvent, perfluoroalkyl substances. Perfluoro basically is a very big issue in the United States these days. I don't know it has reached reach in the Mexico. But in the United States, it's a very big issue. So we need to determine shark if we have these perfluoroalkyl substances. And that is kind of a new thing, so I haven't seen that. And microplastic and nanoplastics coming up. Big things. So how we decide, basically, which one is we need to worry about? Muchas gracias. No need to run. It's fine. No, very, very kind of you. Thank you. Gracias. And so the factor they use is RQ, and that's the ratio. And you can see here, and you can see some red one for pharmaceutical and personal care product, pesticides, and industrial chemicals, those are green ones. But I don't see much in South America and also in Africa. What does it mean? This is so clean there. So no news is good news. That means the measurements are not there. Okay, so that's the reason. So actually, is in Africa is if we can help those population, and in my view, is pollution is always global. That we need to pay attention, because something is somewhere, it can come over here, right? That we have seen in COVID, right? It originated from somewhere, came over here, everywhere. And that's the way, and here is what you see here, again, just to remind you, red one is personal care products, pharmaceutical and personal care products. And you can see here, you see some pesticides, but normally most of it is basically personal care products, pharmaceutical and personal care products. And out of these, you see antibiotics, okay? Because you see in the sulfamethoxazole is sulfonamide, which is heavily used. And then you also see trimpathoprime, because that's what industrial does. They combine the two to give synergistic effect, more effect. So that's what we need to pay attention to. And then you can see some places also we have pesticides and industrial chemicals. And unfortunately, I think sometimes we get just flashy things. Something is coming, then we just run over this thing here. We forget it's still there. Industrial chemicals are still there. It's not going anywhere. Like dioxane and all these things there. And then we have new things coming, like in the United States is PFAS, perfluorocompounds, big news these days. All the funding is going in that direction. And we forget, we still have dioxane, we have trichloroethylene, all things are still there in the water. And here is the different proportion of these ones. Pesticide, industrial chemical, PPCB is 36 out of those what I showed you. And then we have antibiotics. Antibiotics, I think, is very big deal. And I'm worried about antibiotics. Because why I'm worried about antibiotics? Because we are using more and more. I don't know how it happens here. When you see the doctor, in the mentality, I have gone and see the doctor. If you complain to doctor too much, this pain, says how much do you need? He's not asking where the pain is. He's giving you more. And we feel good. And advertisement is going in the TV, ask your doctor. Means you are telling doctor what you need. So this is somewhat funny too. The other doctor is watching you and then giving you. You are doctor, so the pharmaceutical company can sell more. And antibiotics is basically big problem. And this is just to show treatment plants, why we get at the end antibiotics in our system. The source is from drug production, aquaculture, human waste, and animal and food production. You know, of course, human consumption is contributor antibiotics, but most of the consumption of antibiotics, which are keeping the price low, is from animal food production. All dairy farms and all pork and all those things, they heavily use antibiotics. That they release into water. We contribute much, but not that much compared to those ones. And what is going to happen, this is the nice review. Some student visited me from Czech Republic, and we looked the whole global concentration antibiotics. And she is ecologist, so then we looked the ecological health, and you can see very high level in some part of the world, especially in Asia, China, India. They use so much antibiotics there. It has the easy access of those antibiotics. And you can see of those one, sulfamethoxazole, trimethoprim. Again, whenever there's sulfamethoxazole, trimethoprim is there because their industry use the combination of the two. And then is EC50, and you can see for some, they're harmful. And tetracycline is basically for fish bacteria. And doing this exercise, I learned a lot because it can be toxic to some species, but it may not be toxic to other species. So it depends on what species you're looking for. So here is why I'm worried. This is too many antibiotics. That means we'll have antibiotic resistance bacteria and genes. Okay? That means you are taking antibiotics, it's not working. And then you use more, and that will stop working too. Think about this one. You have some bacteria infection and antibiotics not working. It's like COVID situation. We have no vaccine. Same thing, we'll have antibiotics, bacteria is out there, but no antibiotics there to solve. And other sad thing is, no new antibiotics coming because it's not profitable to develop the antibiotics. So all pharmaceutical industry, they are not producing any new antibiotics. I think, so it will be sooner or later, we'll have a problem of this antibacterial infections, like a COVID situation. Think about that one. And we are developing resistant bacteria. I think that's why WHO is saying one of the biggest global health crises of the century, that's antibiotics. And source is basically urine. 60%, they don't metabolize, they are coming out. So it's better to clean the urine, no antibiotics there. And just to show very example, ferret can treat these antibiotics in water. So there's a solution using this molecule. And you can see pharmaceutical can be clean. And if you produce the amino acids, and with ferret, then you have a healthy water too. And as I mentioned, PFAS, I give some few slides about perfluoro compounds. And these ones, PFAS molecules, you can see the CF, many molecules of CF bond. And they are used in many places. You can see his clothing, food packaging, everywhere is used. And then they are getting into water, and you can see they are really harmful. Especially newly born child or fetus get really contaminated with these molecules, really toxic. And this very low level is they are toxic, and we didn't know that. Maybe that's why we are crazy. Okay, and you can see here, even in Texas, other places, we have big contamination of this one here. And here is what I wanted to give you a message here, that these are basically different kind of perfluorocompounds, and EPA, Environmental Protection Agency, keep reducing the safe level. Right now is one they are saying is 0.004 parts per trillion. How you're going to even measure that amount? They're saying it's toxic. And you can see this is really drinking water you can find, and they're really toxic. There's a difficulty of this to treat this one. Why this difficulty actually? CF bond, they are used because they are stable. The application, all application came because they are so stable. And now, how you can treat them if they're so stable? No technique works. And if you look the journals, most of the crowd or scientists are working on advanced oxidation processes to clean something. And this is not oxidation. You cannot treat by oxidation. It needs reduction. And we have trained the people or young these scientists are all advanced oxygen process. You see many journals and everything, but this is not going to work. So we need some advanced reduction to treat these molecules. And this is just to give example about PFS exposure of these, which can reduce the size and hormones growth in the babies. So this is not my work. This is just taken from the literature, and that is will have big effect. And we have done published recently. This is from our lab. We have developed a metal organic framework, which work out very nicely. You can see the solar light, because solar light you can use to break the CF bond. What we learned in this, you need to produce some radical first. Then advanced oxidation process will take over. But first you need that radical. And that what this electron, we need first reduction. Yeah, you can see here, if electron is, we need reduction, and then hydroxyl radical will come in a picture. And we have written a review article recently about this, how you can use even electrochemical degradation. Here is the other problem to solve this any pollutants. We can determine any pollutant concentration, then we need to look for the solution. And any antibiotics, any pollutants, they'll be surrounded by natural organic matter. And they are much higher concentration. They can be in micromolar or micro-nanomolar level of the pollutant, but they are in milligrams, natural organic matter. How you're going to solve? Advanced oxidation process fail. Reduction will fail unless you remove the organic matter, natural organic matter. Otherwise, all technique will be not effective. But then, even you remove by activated carbon some technique, you're just concentrating it. You still need to take care of that process, of that contaminated solid. But concentrate may be easier to treat. One thing is you just burn it, then you put some gases in the air. And you can use some plants. Here is a PhD student, she reviewed it, and she is working on this, how different plants can take this PFAS, these compounds. And these can be taken, and some of, I don't know how much study has been done in Mexico. Mexico may has different kind of plants, and maybe they can take of this one. But she's originally from Nigeria, so she's looking for some plants that are specific in Africa. And that's what we are looking, if they can take these compounds. So we can phytoremediation. And now I come back to last section of my presentation is on in the plastics. we are using too much plastic. Here is the budget for plastic basically showing. In here is the sentence I will just read. In Europe and North America, the amount of microplastics transferred every year from wastewater treatment plants to agriculture soil as biosolids greater than the total burden of microplastics that is in the ocean. And this is a budget. If you're interested in this, the budget is given this one. And basically, human activities, plastic, mulching, we are using a lot, crops and fertilizers. Even we have cookies outside, very tasty cookies, but they're wrapped in plastics. Has anybody tested microplastic there in those cookies? Okay? And you can see livestock, soil organism, humans, but they taste good, by the way. I'm not destroying your cookies because I am eating too. And this microplastic goes to this here, and this is what I want to convey to you. Particle effects, chemical effect, microbial effects, those can be there on microplastics, and then exposure can happen too. And how we are getting exposure, they are all going to our lungs. And back to what I was saying, or Jonathan invited me, or Dr. Judy, about climate change. Climate change means we have more solar light, more warming things, right? They are going to form more nanoplastics or more microplastic. More aging will be faster. What that means? Nanoplastics are even more toxic, potentially more toxic than microplastic. Do you believe this, what I'm just saying? Nanoplastic will be more toxic than microplastics, right? And that means climate change, you're producing more nanoplastic. And very nice, if somebody's new student working on, I encourage them to read this article in Chemical Review. They really tell what kind of plastics, different functional groups. They are different kind of microplastic or plastic that industry is producing, and how to analyze. That's very important. It's not easy process, by the way. Maybe Mexico City or someplace, you can send sample to analyze these ones. It's not easy to analyze this one, but you can see all is chemistry. And that means if you are eating cookies, you are taking all this chemical inside too, possibly. Don't? Okay? And this is just showing where different microplastic particles are coming from fiber and different foam, different seafood. This is studies done here from honey to everything we are using plastic. At least United States is based on consumption. I go to grocery store, probably end up 10 bags. Here I notice people take their own bag and they put there and they reuse again. And you know what is the percentage of recycling? Very low in the United States. I don't know about Mexico. Very low. And one microplastic is there, they degrade to biological degradation, chemical degradation, mechanical degradation, and photo degradation. So all these processes, what I'm trying to say, all these processes, mechanical degradation, and it's why it is important for climate change. More hurricanes will come, that we are already seeing. That means more agitation is happening. That is going to release more microplastic and nanoplastics. And then chemical degradation increase, our reaction depends on temperature. Biological degradation, and of course photo degradation due to light. And that's going to happen. I'll give example of each one. This is, I'm not going to explain, but here is especially the young one I like to challenge. The biological degradation happens of plastic, biological degradation, right? So why don't we make those plastic which can be biologically degraded? If you chop, then we don't need to worry about this plastic. So that means you can develop some enzymes I think that will be the future. Next 10 decades, next 2 or 3 decades, somebody will get the Nobel Prize. That's my prediction. Just how you can develop some particular enzyme that can chop these things. And then you don't need to worry about these plastics. Yes, please. Sorry? I don't know the very good question, but question is use anaerobic bacteria or use aerobic bacteria, basically. I think this is still in progress. Is in progress. Both? You know probably more. Is both. But I think it's still in progress. The paper I saw in Science, somebody has done this thing. They are chopping it. And this one, this plastic. PFA, I'm always confused with PFA. Go ahead, sorry.
Yeah.
Go
I think that the main challenge to investigate about nanoplastics and microplastics is the techniques to analyze them.
Yes.
So that is a real challenge.
Yeah, that's why I put this article to challenge everyone, especially the young one who are involved in this research, to really careful. Otherwise, you get some data which misleading. Go ahead.
Yeah. But the main challenge, I think, that is in the analytical. Thank you, Professor.
I requested they can ask question anytime. And there is photo aging of, because all these different groups can be affected by the light. And these papers are coming out how to degrade these ones. And here is my lab paper. This is really getting high cited. Is chemistry of these ones. They can aggregate. They can be again surrounded by organic matter. Organic matter is there. And these are just to show different type of different media. Again, what I'm saying is probably there are many here marine chemists or marine science. So salinity has a lot of effect on these microplastics. Salinity. Salinity of seawater, that also effect, because ionic strength and aggregation and then charge, they all determine the behavior of this microplastic in the environment. And this is showing the functional groups. Not only that, what are the surface charge, different functional groups that also will determine the fate of this microplastic and nanoplastic in the environment. That means also affect the toxicity of these ones. And here is, this is figure 1, you see this is a proposal I'm writing, how these different understand the mechanism. Because once you have climate change, we'll have more light. That's going to produce more radicals and more reactive species in the water, especially surface of the ocean or surface of the coastal water. How these different radicals going to affect the microplastic fate. Yes, please.
Many times the organisms are adapted to live with the microplastic using as material to build their homes, their houses, to use.
Could you please repeat?
I think organisms use the plastic and live with it,
Oh.
like
So
us.
well, saying is that's happened for every, if you think this way, what she has a comment, do we really need to worry about this, because organisms will adapt anyway. That's your human will adapt too, basically, up to certain extent. That's the question. basically. Because what is going to happen, not only microplastic or nanoplastic, but they are not alone. Because if you see the next slide, just give me a couple of more minutes. Here, they're all contaminants are being absorbed on these ones. So you're not getting only nanoplastic or microplastic because the absorption is happening of those contaminants. Not only that, biofilm are being formed. And that will also, bacteria and those will go to microplastics. Just here, which I'm showing is algae, bacteria, all this going to the microplastic, this one, and that will be more dangerous than not only itself alone, those microplastic and nanoplastic. This film will form, which is already happening, and that will take the bacteria, and that's happening in hospitals too. We have sheet of plastics, and then they enjoy that kind of environment, those bacteria and viruses. I'll close soon. And this is just to show, article came just this week, Chemical Society Review, how to solve water treatment and many others ones. Is the cover page, they gave the cover page. This is a new topic, is single atom catalyst, which I started in my lab too, and that will also be good to solve many problems. And so my story continue. I like to enhance international collaborations, so we solve many problems all over the world, and then learn about the fate of chemicals and contaminants, including microplastics, and so we can produce, once we know the problem, then enhance the decontamination of water so we can have a clean water to all the global population. That's my mission. So with this, I say muchas gracias for listening.
Thank you very much.
Comments are very welcome.
Thank you very much, doctor. ¿Algunas preguntas? Puede estar muy breve, por favor.
Thank you, doctor. I don't know if I understand well, but I asked you about the activated ferratum solution. Do you use the solution with antibiotics to absorb antibiotics or only plastic? I don't understand.
Yeah, I will explain, because I did not talk about. See, what she's asking, ferret, and I'm also using in one of the slide activated ferret. And ferret has different forms, okay? Ferrous and ferric, but we have then ferret 4, ferret 5, and ferret 6, okay? Ferret 6 is what normally people use, but here if you can produce 4 and 5, they are called activated ferret, because they are activated, they can kill more. If there's some bacteria you cannot kill by ferret 6, but ferret 4 and ferret 5, they kill it. And that's called activated ferret, because they're more, that I meant by activated ferret. And which you can produce from 6 by 1 electron or 2 electron, because you need to bring 6 to 4 and 5. And that is which I was saying amino acids can do, or some of ascorbic acid can do. So you take ferret, then put vitamin C, or maybe put orange juice, and then create activated ferret to kill bacteria. It's more pure and healthy water.
And about the pharmaceuticals, do you investigate in the marine environment? Because right now, I have a test using filters in the seabed, near to the seabed, and right now I send that filters to measurement carbamazepina, ciprofloxacin, sulfamethoxazole, and we have some results about sulfamethoxazole in marine sediments. And this kind of pharmacy is in the surface, but not at the sedimentary column. The sulfamethoxazole is only in the surface. And well, I really interested with your investigation, and thank you for explaining.
Yes,
now.
for ferret is very easy, sulfamethoxazole, because ferret like the sulfonamide group, it can attack and kill it. Problem is CBZ, but we can do it in using the activated ferret. So we have, first we try with a simple ferret, that is 6. If something doesn't work, we bring 4 and 5. So big guy, macho comes. 4 and 5 are macho. We bring macho ferret. Yes, please.
Thank you, John. You were talking about climatic change. That's the problem in your presentation.
Yes, I was challenging everyone.
Yeah, right. You were showing a map, a global map, where Mexico, we don't have a lot. And I can tell you about the oil spill in the Gulf of Mexico. What's the interaction with the pollution you were talking about and this problem, oil spills? And you know we have a lot in Mexico, in the Gulf of Mexico. Right now happened just a few days ago. So the interaction with the plastic, microplastic and nanoplastic, what's the problem there?
So if let me rephrase the question there, or your comment you're making, so I make sure I understood. You're saying is, what is the relation between oil spill and microplastic and those ones, right?
Right.
So actually, microplastic and plastic, they're a kind of hydrophobic environment. And oil and those are also hydrophobic. So there'd be hydrophobic interaction. So they will go and sit. I haven't done myself yet, but they will go, those oil drops or all, they will sit just nicely on the microplastic and nanoplastics.
Oh, I see. Okay.
But this is good to investigate, just to see where are they hydrocarbon after the oil spill. It's a good project, you can write.
Thank you.
Yes, please. Thank you. I was giving rather than normal talk, actually I hear is more kind of provoking talk a little bit.
Is there any regulation about production of nanotechnology? Because in Mexico we don't have it. And we are really concerned about the repercussions of nanotechnology in human health. I mean, in everybody health, but in human health. Because as you know, Dr. Ragusa have shown that you can find microplastics in placenta and in the newborn. So the problem with nanotechnology is that the small particles are able to go into the cell, and we don't know yet what are going to be the consequences of these interactions at the cell level.
Yes, at least in the United States, question is that just to repeat, nanotechnology is growing in Mexico, that you said, right? And what do you think, okay? What is the effect to the human health about that growth of nanotechnology? Okay. I only have experience of following the literature in the United States. There's no regulation there. Initially they started paying attention, but suddenly I see field is kind of disappeared in the United States. Nanoparticles and those ones, there are not many papers that are coming out from the United States. And my suspicion is, when I say suspicion, I don't have strong evidence. Most of nanotechnology that was coming from the United States was silver nanoparticles. And what they realize, first thing they have is a lot of struggle to, or controversy, or find it out, which is really silver ion is doing effect, or silver nanoparticle is doing effect, which is zero oxidation state. So that controversy never ends. then they found it's just silver iron. Most of the, maybe they are winning the argument about silver iron. If silver iron is doing, which is already there, why we care about nanoparticles? So regulation-wise, the United States in general is not that strong anyway, regulation. And other countries, the regulation, European Union comes out, but they are slow process. So Mexico, I don't know enough to comment further. Okay, thank you. Again, you can make all kind of regulations, but then still need implementation. Yes,
Gracias.
any other, no question, comment? I can go home now?
Thank you very much for your wonderful talk and your inspiring talk on microplastics, because many people from IPN, we work on plastics as well as microplastics. So hope you will get more interactions as well as more requests for future collaborations.
Yes, I'm very looking forward to tequila, yes.
Now let me, on behalf of Red de Medio Ambiente, let me read the certificate. Instituto Politécnico Nacional, 5th International Conference of Environmental Researchers Group, IPN CIIEMAD 2023, Our Planet and Our Future. This is to certify that Dr. Virender Sharma has participated and presented an invited lecture on impact of climate change on microplastics and nanopollution, organized by Environmental Network Researchers Group, REMA IPN. Below you have the signature of the coordinator, Dr. Adriana, and as the coordinator of the event, Dr. Jonathan. And we also have a small gift for you to have coffee in your office, especially.
Thank you so much.
And this is another gift from the organizing committee and as well as the Indian friends who went to field. They were not there. Okay,
Oh,
so
thank
it's
you
also
so much. Muchas gracias.
Muchas gracias. Thank you very much for your invite. Muchas gracias a todos. Con eso terminamos la sesión y le vamos a empezar. La maestra Lula va a anunciar.
Dos comerciales, no se vayan. Un comercial es que antes que se vayan al cafecito, en esta misma sala se va a presentar el tema nuestro medio ambiente, biodiversidad, recursos y bioremediación, y estará coordinado por Miguel Ángel. Se fue a colectar, entonces estará la doctora Guadalupe González Díaz, se encuentra con nosotros. Macha Lupita, usted está, la que sigue. Con mucho gusto regresen aquí y gracias por su participación a todos y vayan al cafecito.
También en Salón 2.